Welcome to another video. In this one, I'm going to go over two different ways that we can create volumetrics within Maya when using Arnold. Now, the first method is pretty straightforward in terms of its setup and practical application. It allows us to create an added sense of depth within our scenes quickly as well. That being said, it does come with a pretty significant downside, that being it does not allow us to create a volume AOV, which drastically limits us in our ability to create any isolated comp adjustments. Now, the second method addresses that, where it does allow us to create a dedicated volume AOV, allowing us to separate those volumetrics from our beauty pass so that we can do any of those isolated comp adjustments if needed. Now, that being said, it does require a little bit more setup, but it's still quite manageable. I'll also go over two different render layer techniques, which will give us even more control over our volumetrics. One will allow us to isolate our volume sources to individual layers, and the other one will allow us to isolate those volumetric sources to the RGB channels on an individual layer. That being said, let's jump on into the first method. Method one, let's do this. So you'll see I've set up this abstract scene with these spheres. I've created a few area lights and I've hid them visually within the render view between each of the spheres just to get a sense of depth. Next, you'll see I've done a render where we don't have any volumetrics visible. So next we would just need to do the thing. So let's go to our render settings, and then within the Arnold renderer tab, we would go down to the environment section, that drop down. You'll see an atmosphere input there. You just click the checkered box, and then you'll see a couple options: create AI atmosphere volume and create AI fog. You'll also see I have a third one here, AI atmosphere volume. That's because I already created one when I was testing earlier, so I would just select that. You would, of course, need to create it if it's your first time making it within the scene. You'll also see that the default value is 0. So I had 0.008 as the final value I used. So I'm just going to reset that to 0 in this case, as you'll see. Now, with it set to 0, if you do an IPR render or any kind of render, you won't see a result at all. Of course, that's because the density is set to 0. So you'll need to increase that value. As you do, you'll start to see a result and see those volumetrics within your render. Now I'm going to set it to 0.01 here. That's often a good starting point, and then you can push and pull it from there to further refine your volumetrics. And so I just landed with 0.008. If you wanted to adjust them beyond that, you can. If you have, say, dedicated volume lights within your scene, you can just adjust the intensity of those. Otherwise, if you just have a base set of lights that are affecting the geometry within your beauty pass as well as the volumetrics, you can just adjust the volume visibility on your light settings for the individual lights to determine how much you want each of those lights to affect the volumetrics within the scene. Now you can see the AI atmosphere volume material that's plugged into the atmosphere input also has these other settings. You can change the color. Maybe you're working in an underwater scene and you want to push the color more towards cyan globally. You can do that, of course. Now I'll often change the color in comp, but in some cases you might not be able to. Maybe as a lighter, you might not have the freedom to make those adjustments in comp in certain production scenarios. And so you'll just need to do it out of render in those kinds of situations. You can also adjust the attenuation color, anisotropy samples. I'll let you look at the tool tips regarding what those do for you. Feel free to test them out. I'll often just leave all of these at the defaults though, and then just adjust the intensity otherwise, and I'll usually be good to go, with the exception of maybe some rare cases. But again, feel free to test these out yourself. So that sums up the first method. As you can see, it allows us to achieve a quick out-of-the-box setup. Now, it does come with a pretty big downside, that being it does not allow us to separate out our volumetric result, limiting our ability to make any kind of isolated adjustments to our volumetrics in comp. So I'm just going to go back to the render settings here and then to the AOVs tab. And then within the available AOVs list, I'm going to go select the volume AOV and move it into the active AOVs list. Now, when you add it, you shouldn't need to do anything to the settings for it. It should be good to go as is. Commonly, you should be able to see a result from the AOV that you've now created. So I'm just going to, with the new IPR started, select that volume AOV, and you'll see that it just produces a black result, which we won't be able to do much with, right? And so that is to be expected, as Arnold only writes volume AOVs for actual geometry volumes, things that rays physically intersect Environment or atmosphere shaders are treated as background effects, so they don't register in the volume path. So to include them in a volume AOV, you need to assign an atmosphere shader to a real volume object within the scene. And so that's what we'll do in the second method, which will resolve this issue for us. And so it's a little bit more of an involved setup, but I think the upsides do outweigh the downsides. So let's jump into the second method next. Method 2, let's dive in. So first of all, you'll see I've just created a cube within my scene, and then I name it geo_VolBox. Now you can name it whatever you'd like, of course. That's commonly what I will use myself. I then scaled the cube up to cover the entire scene or the environment within my scene. Now you don't need to make it unnecessarily large. It only needs to cover the area where your volumetric lighting will be visible and stay otherwise outside of the camera to avoid artifacts and any potential flickering, which can commonly happen if you're doing any type of animation especially. Now, this is just how I scaled it initially. I did end up going back and rescaling it to make it a little bit tighter to the environment. Now, once you have your cube generally positioned and scaled up, you will want to apply an AI standard volume material to it. So you can just right click on it and then go assign new material from there. And then you'll see the assign new material window pop up. You can then navigate to the AI standard volume material, which will be found within your Arnold shader menu. You can also search for it in the top input box at the top of the window there as well. Now, once that shader is assigned, you can go into the settings for it, and you'll see you have a plethora of additional settings. That's because it's often used for other VFX as well, whether it's smoke or what have you. In most cases, I'll just use this for environmental haze when I'm lighting. And so I'll just stick to commonly that density value, and we can just preemptively otherwise set that to 0.01 to start out from. And then again, we can adjust that as needed from there. Now you'll also see that when we applied that shader to it, the cube turned green. And so to satisfy any OCD you might have in relation to any dropped material connections, you can just open up the hypershade and then click the input output connections button. And then you can click that shading group and then click that button again, and you will see the connections there for it. You'll see the out color from the standard volume is going into just the volume shader. And since there's no connection being made to the surface shader, it's recognizing that as a broken connection. So to resolve this, you can just plug the out color into the surface shader, and that will satisfy your OCD and it'll fix the issue. Now, you also don't need to do that necessarily either. You can also go to the shape tab for the cube with the cube selected. And then you can go into the object display dropdown, and then under the drawing override section, you can enable overrides, and then within the level of detail, select bounding box. That will then also satisfy your OCD regarding that. And then you can just navigate around your viewport with ease, where you can easily see your scene and work within it without having to zoom in and out of that box. Now here you'll see I've then just, as I stated before, just rescaled that cube a little bit more just so that it's tighter to the environment, as I noticed it was a little bit excessively large. So I just kind of brought it down in size a bit. Now, if you do a render with it set up in this way, you'll see that it just produces a black frame. And now as I move over the cube, you'll see why that is. The volume box itself is just rendering purely black. So to resolve that, when you're using Maya with Arnold as your render engine, what you need to do is select the cube and then go to the shape tab again, go to the Arnold dropdown, scroll down to the volume attributes section, and then just give it a step size. You could give it something like 0.1, and then you should be able to see a result there at that point. Now you'll see I also saved out a render from that first method in my snapshots kind of catalog at the bottom of my Arnold render view there. And then I just went and saved out a snapshot of the second method's result as well. And then you'll also notice that I saw that the results were looking too similar, and I discovered that that was because I still had that AI atmosphere volume material plugged into the atmosphere of the environment in my render settings. So I wanted to kind of kill that to resolve that, so I just right-clicked on it and broke the connection, and that resolved that issue. I then deleted that snapshot and made a new one to compare that to, and that fixed that issue. Now you'll see that the result looked a little bit different, but it wasn't a big deal because I didn't have a clear target or creative direction I was going for anyway, so it's not a big issue. You can always push and pull your dedicated volume light values or your kind of base lights in terms of their intensity or their volume visibility to kind of get it closer if you wanted to. And that's what I ended up doing here for the top light. I just increased the volume visibility just for that light to 1.8. Now we're at a very similar place as we were with that first method, just using a different approach to set up our volumetrics. Now I'm going to show you how we can solve the issue before when we couldn't get a result coming out of the volume AOV. So if we go to the render settings again, you'll see that we still have the volume AOV active. And now if we just do a new IPR render and then go to the AOV dropdown, you'll see that we have the volume AOV result showing up here within our render. And so this would effectively just be contained within that single multi-layer EXR file that we might end up batch rendering out or saving out. Now, you'll see that it's also quite noisy, so we would want to denoise this if we didn't plan on denoising our result in comp. So to do that, you can just go to the display settings panels on the right of your Arnold render view and the post tab, select that default Arnold denoiser, which it looks like it's set up by default in the newer versions of Arnold. And then you can just click on the select AOVs button. As you'll see right now, it's just denoising the RGBA. That's the only layer that it has added there by default. But so once you click that select AOVs button, you can then just shift select or option select all of the AOVs you want to be included or affected by that denoise imager, and then click OK. You should then see them added to the input box in the layer selection area, separated by the word or, and that will indicate that they will then be getting denoised. It should also show up in the Arnold render view there in that input box. In this case, for some reason it wasn't. I think it might be because I manually deleted it prior. And so, I don't know, it might have been glitching out or something. But in either case, you can see that it's clearly getting denoised in the Arnold render view, and so it's doing its thing. And so that said, that is the second method, and it gives us, again, a little bit more control at the end of the day, allowing us to separate out our volumetrics and adjust them as we might want to in comp. Now, we're still a little bit limited since we can't isolate out these volumetrics in terms of their individual sources and adjust them independently. Based off of the light sources that are affecting them, but we'll go over a couple different approaches again through the use of a couple different render layer techniques next. With both of these render layer techniques we're about to go over, you can use them alongside either of the two primary methods we already covered previously. If you're using the render settings or environment atmosphere approach, this setup is probably simpler since there's less overhead to manage. If you prefer more control, however, the VolBox method seen in method 2 might be your cup of tea. Both approaches work fine here because the volumetrics are being rendered onto their own render layers rather than as a volume AOV or custom light group kind of setup. It really just comes down to personal preference and workflow. Right off the top, you can see I've already rendered out results from the 3 render layers I had already set up. Each of these correspond to each of the individual lights that exist within this scene. Now, depending on your scene setup, you can group however many lights you want onto a corresponding render layer. If you have a bunch of street lights, for example, you could just put all of those on a render layer and then a different type on another. But this is just how I set it up for this scene. So you'll see I have a render that I've saved out for the top light render layer, and then one for the side near light render layer, as well as one for the side far light. Each light then is isolated into its own render layer and it's ready to be comped. Then I also rendered out and saved a snapshot of just the clean beauty pass that I set up for this workflow as well. In my main scene layer, I've kept a clean render with all of the volumetric visibility turned off on the original lights. Then I duplicated those lights, renamed them with a vol underscore kind of tag near the end of the name for each, and then I put them into a dedicated volume light group. I didn't change their volume visibility from how it was set up in method 2. The top light's volume remained at 1.8 and the other 2 were set to 1. I might have actually duplicated those originals before even doing anything to those, so they just retained those values, and then I just set the originals to 0 for their volume visibility. And so ultimately at the end of the day, those original lights were not contributing any volumetrics on the main scene layer, and then the duplicate versions were acting as volume only lights. For the render layers themselves, I assigned the corresponding light to each one and used overrides for their visibility. By default, all of the volume lights were hidden in the main scene layer, and then I simply enabled the one that I needed for each of the layers. This avoids extra overrides and kept the setup efficient. Each render layer also has a shader override applied to all of the geometry. A simple AI utility shader set to black did the trick. It effectively acted just as a black surface shader. That creates a clean mask for the geometry so that the volumetrics can layer back over the beauty pass and comp without interference. So the big upside here is ultimately flexibility. You can render just your volumetric passes without having to touch the beauty and re-render it. and you've got isolated control over each volume source in comp as well. You can adjust the intensity, color, or overall kind of blending of the volumetric passes however you would like, with zero impact on the rest of the scene. The downsides at the end of the day are, first of all, file management. You'll end up with multiple EXRs that correspond to each render layer output, one for the main scene layer, and then a single EXR for each of the other render layers that you might be setting up. And so just managing that would add a lot more overhead to the project you might be working on. So this is not always the best approach in regards to that. It also means more files to work with on the comp side as well. In addition to that, there's going to be more overhead in terms of the Maya side setup as well in relation to the render layer setup for each of the volume sources that you want isolated control over. That being said, though, depending on the project you're working on, it might be just a personal project or a one-off job. This can be a reasonable approach, and that extra level of control can outweigh the level of overhead that you might otherwise encounter. But that's the essence of this setup. Next, we'll explore another render layer technique and compare how it stacks up. Render layer trick 2, let's get into it. All right, so for this technique, we are grouping our volume sources into the RGB channels, essentially into 3 primary groups. Now, we are effectively limited to those 3 groups, but for my experience, that is plenty enough. So again, as you can see, it's just a single render layer setup that we can see within the render layer window, where I have the render layer and the underlying collections named accordingly, with that RGB tag included as a descriptor. And then in that top level objects add collection, you'll see that I've just made sure to include all necessary elements or objects within my scene to produce the result that I need to on this render layer. And so I've added the camera, all of the geometry, the volume box, as well as all of the lights. And then that second collection is set up the same way as in the previous technique as well. It's just the shader override collection where I'm adding all of the geo within the scene to it, the geo group. And then I added that AI utility shader once again as an override to that collection so that it gets applied to all that geometry that's on it. And then I changed the color of that AI utility shader to black. Now for the last collection, it's named very similar to the last technique where it's just called lights on vol and then RGB pass. And then that is then overriding the visibility of the group in this case to be turned on for this layer. And so all we're doing is adding the vol lights group to this render layer, to this collection. And as you'll see, we're currently on the main scene layer. It's hidden by default on that layer. And so then if we switch over to the vol RGB layer, you'll see that that light group then becomes visible if you look at the outliner and of course the render. And then how did I color them red, green, and blue, you might ask? Well, you might have also guessed if we click on the area top vol light, as we can see in the render, it's red. And then when we go to the shape node, the light attributes for it, you'll see I changed the color to a pure red color. And so that is important. If you double click on the color picker there to bring up the color picker window, you'll see that the R is set to 1 and then the G and the B are completely zeroed out. You would want that for each of these color values, the red, green, and the blue. It will just be much easier to isolate out these volume sources in comp if you make sure to do this. Then you can easily adjust the intensity or the color of each of your individual sources as you might want to. Now keep in mind if you're working in different scenes where you might have similar light types such as street lights, stadium lights, or flashlights, you can of course group these into the corresponding channel that you might want to isolate those sources out onto. So you could put, say, all your street lights into the red channel, and then maybe all of your flashlights into the blue channel. Maybe you have a car driving down the street, you could put its headlights into the green channel, and then you can pull those apart in comp and adjust their intensity, color, what have you. But with that set up, this, in my experience, is the simplest way to use this approach, since all you have to do is create duplicate versions of your original lights that would be used for a volumetric contribution, and then name them accordingly. And then all you'd have to do is just hide that vol lights group on the main scene layer, and then create an override for it to be visible on the vol RGB layer. Then if you want to adjust certain attributes, for example, the spread or the intensity or which lights are going to be grouped onto the R, G, or B channels, you can do that right on the light sources themselves. And then of course it won't have an effect on your main scene layer since that group is hidden on that layer. And only those original lights are affecting your scene otherwise. This strikes a good balance between a not too complicated layer setup and while maintaining a fairly streamlined setup within your actual scene and within the outliner. Now, you could alternatively not use these duplicate volume dedicated lights and just delete this group outright, or not create it in the first place. And then you could just use these original lights instead. You could keep their volume visibility then at 0 on the main scene layer, and then override it to be on, to be turned up to 1, or whatever specified value you want them to be on the Vol RGB pass or layer. You could also create sub-collections within a top-level collection to specify specific volume visibility values for each of your lights as well. In addition to that, you could create multiple different overrides adjusting the spread or intensity of each of your lights, amongst other attribute adjustments. But if you did it that way, you're going to end up with a whole bunch of collections, sub-collections, different overrides adjusting various attributes on each of your lights, and the layer setup's going to get a lot more complex and involved. Granted, it does simplify your scene in terms of what's visible in your outliner and the amount of elements that you would then be working with within your scene otherwise. But again, the downside here is that it does complicate your layer setup by quite a lot. So I like this approach. You can do whatever works for you based off of the project that you're working on, whatever floats your boat. But this, at the end of the day, is the second render layer technique. Next, we'll go over how we can composite these two primary methods along with the two render layer techniques in Comp. All right, now that we've gone over how to set up the volumetric passes in Maya using both the AOV and render layer techniques, let's jump into the comp side of things and look at how we can actually work with them. Now, as you can see here, I have 3 of the different approaches laid out here in Nuke, each within its own backdrop and with its own heading. I just used sticky notes for those, adjusted the color of them, and then the font size. And then you also see I have the corresponding footage that I've brought into each of these respectively as well. I just batch rendered those out and they went to the specified directory based on where I had my project set on my hard drive, and then I just dragged them in to each of these setups. Now you'll see again, the first render layer technique has a few more outputs or results, EXR files as it were, that we're dealing with because we had those 3 different render layers for each of the volume sources that we were working with. Whereas this one has 2 because we just had that single RGB render layer for the second render layer technique. And then we also have the beauty pass, the main master layer or scene layer result for each of these. So that one also has it, the first render layer technique. And of course, the first method has that as well. And that is the only EXR file we're working with in the the second method. So now let's go through each of these approaches and compare the different kind of control that they give us. So as you'll see, I don't have the first method set up here. That again is because we effectively had the volumetrics just baked in to that final beauty result. So if we just take this, copy and paste it over here, all we would get is this, right? We wouldn't have any kind of embedded volume AOV that we could kind of pull apart as we did here with the second method and then add back on top and do adjustments to it. We would essentially just have this. That's why I didn't bother setting anything up for it. All we could really do if we just create this grade, hitting G to create it, the hotkey for it, and we double click on it to bring up its settings, all we could really do with that is just increase uniformly the gain or decrease it, the brightness as it were, or adjust the color of it. If we did that, we would be affecting the entire beauty pass, right? So that, of course, is that primary limitation to the first method, is that we don't really have any kind of control over the volumetrics in Comp after the fact. Now, again, some of the time, this isn't an issue. You can work around this. It just means you have to spend more time iterating, testing early on to make sure that the volumetrics are going to look the way that you want them to out of render. So you just have to spend a little bit more time measuring twice or 3 or 4 times so that you can make sure that you're ultimately, hopefully, going to cut once after you end up rendering your final result. Whereas with these other methods that we've output here that I've set up, we have a little bit more flexibility because we can, of course, have a little bit more fine-tuned, isolated control over them in Comp, and that's the whole benefit of them, which is why I'm going to show you what I'm going to show you. So let's just delete these nodes here. Now getting into the second method. Now again, this one uses that AOV approach, and so here, again, I've just batch rendered out that file, and then this is the EXR that it gave me. I dragged it into my node graph, and then I just shuffled out the volume AOV result, which gave me this. You'll see that I've created a few dot nodes just by hitting the period on my keyboard for the shortcut to create those, and then I just have that beauty result piping through here into the output of the merge node down here. And then what we have going into the B input of this merge is that shuffle node, which we have specified to be the volume AOV going into the input layer, which is then piping into the output layer RGBA, so that we can see that result here. And that's being piped in again to the B input of the merge, with that set to minus for the operation. That then is effectively minusing or subtracting this result out of this beauty pass, leaving us with this kind of clean underlying beauty result here, so that we can effectively then just copy this guy down here. That's what I did over here. And then if we go to the node tab, I just turned on postage stamp and hide input. And then that allowed me to see this preview of what we're seeing here within this shuffle result. And then by hiding the input, it allowed us to do exactly that, hide the input, which kind of keeps a kind of cleaner setup visually, preventing those kind of overlapping input arrows, just to kind of make things a little bit more visually clear for us. And now what we have is then that being piped into this grade node, into the input of this merge node, which is set to plus for the operation. And then we have this clean underlying beauty pass, which we got again from this right here, and that's being piped into the B input. And then we also have a roto shape just to kind of show you what we can do with this in terms of the isolated adjustments. So if we want to do any kind of rotoing or masking out certain areas of the volumetrics here, we can do that, but again, it would just uniformly affect this volume AOV result. So we are a little bit limited in that, but we can still do it. So this is just that here where I just created this roto node. I just hit tab, typed in roto, arrow down, hit enter to create it, piped in the mask from the merge into the roto, and then I just, with this root folder selected, click my Bezier, and then I started clicking some points to create that. You could also click and hold on this, create just a simple ellipse or rectangle, what have you. Click on this to add points or remove points. And then you can hold Command or Option, I believe, if you're on Windows, to just add and remove those points. And that's what I did there, just to kind of create that mask and kind of mask out some of those volumetrics. And then what we can also do, if we just view this and then click on that grade, we can adjust the volumetric color again, just cool them off, or we can warm them up. Similar to what we were doing with them on the Maya side previously, but now just in comp. We can also adjust the multiply value to decrease the intensity or increase the intensity of the volumetrics. We can also adjust this vertical slider here, which will just uniformly adjust these RGB values, darkening or brightening the overall volumetric result. So this gives us more control for sure than the first method on the comp side of things. However, we are still quite limited in that we don't have any kind of isolated control over our volume sources within the final result in comp. This will often depend as well on how much you've kind of dialed in your volumetrics out of render. If you've spent more time to kind of refine them out of render, this setup may do you just fine. Now, going on to the second render layer technique, this is where it gives us even more flexibility over the individual volume sources and adjusting those. So this is where we set up those multiple render layers. If you go back to that first render layer technique in the video, that's what we did here. We set up the clean kind of beauty pass without any volumetric contribution on it by just dragging down the volume visibility on our lights, our original lights, to 0. And then on the corresponding volume layers where we had each of our individual lights assigned to them, we then set overrides on those to just be turned on. And then the volume contribution for those was kind of just predetermined, pre-set up, and specified otherwise. And so this one, I believe, was set to 1.8 for the volume visibility. And then these ones were set to just 1. And then I also had the color of them out of the box just set to white. Now, we didn't need to set up any overrides. If you recall, we just turned on each of the lights that we needed to for each of the corresponding layers. And this was the result that it gave us. And so then when I batch rendered out that file, it gave me these 4 different EXR files that I then just brought up into this node graph, into this setup. And then I was able then to make these kind of isolated adjustments as I might want to. So if we just view this merge node down here, which again is set to plus, with then this clean beauty AOV over here, this EXR being just piped down into this dot and then into the A input of this plus. We then have our vertical volumetric pipe being piped into the B input. So if I just go back up to here to that grade that's after the top light volume pass or layer, and then we just make some adjustments to it, you'll see then we have this kind of fine-tuned isolated control over that source, and we can adjust it as we might want to. We can warm it up, cool it off, do whatever we would like to it. We can also do the same for this side far light. We could warm that up if we wanted to alternatively. We could, for the side near light, maybe we want to increase the intensity of that. We could do that to that one. We could do whatever we want. The world is our oyster. And we could also create some roto nodes, as I did here, just to kind of bring in that effect and kind of draw the attention more to the center of the frame and vignette things just a little bit there. And then I also created a roto just kind of bringing in that top light effect in the context of this result as well, just to kind of focus that result a little bit more to the top center of the frame. I probably could have done that roto down here as well and then just kept this as a dot node, but this also worked. It just might have resulted in one more node, but that's all good. Now down here, you could then also do kind of global adjustments, which would then affect all three of these individual results or files. And so just by creating this grade node down here and then adjusting the multiply, bringing it down or up, we can then globally adjust the intensity overall of the volumetric result with this setup. And so that is another kind of thing that you can still do here with this method, in addition to having the isolated control that we get with it as well. Now going over to the second render layer technique or trick, we have the RGB approach, where we isolated our volume sources into the RGB channels on a single render layer, right? And so that's kind of the benefit out of Maya with this setup, is that instead of having multiple render layers per each individual light source or volume source, we just have a single render layer with each of our volume sources isolated into the RGB channels, giving us effectively three groups that we can kind of use and manipulate after the fact in comp, pull apart, and then add back in using these shuffle nodes. So I just have these three EXR files, or sorry, these two EXR files that it output after I batch rendered this file. I again have that clean underlying beauty pass with the volume visibility on the original lights turned to 0. And then I have the RGB layer, where I then again just set an override to turn on the volume lights group, where I just had kind of preset each of the lights to be that pure red or green or blue color. And then I just created these shuffle nodes that have their B input connected to the EXR here. And that is the same for each of these. I again have the hide input and postage stamp turned on for each of them, just to kind of see the result that we're working with. And then through shuffling out the red into the RGBA for each of these shuffles, it gives us this kind of white mask, or just kind of final beauty RGB result, as it were. And then I'm just color correcting it. I'm just grading it as I wanted to. And then I'm using basically the same setup as I was in the first render layer technique. We're just using these merge nodes set to plus. That one again could have potentially been a dot piping into here, and I could have just rotoed this one instead, but all good. And then if we just step down through the pipe, you'll see what that's doing for us. We go over to this bottom merge where we have the beauty result again going into that A input of it. You'll see what's going on. So again, we have this complete isolated control setup where we can increase the brightness of our individual sources. We can change the color of them, warm them up, do whatever we want here. And now I should say, which I had a bit of a, I think, text overlay at the last chapter, which I added to this, this video. I did notice a quality degradation when I used this setup, this RGB render layer, while using the default Arnold denoise imager. Once I switched it over to the noise denoise imager, it did improve the denoising result and helped out for sure. Now, you might still notice that as we adjust these, there's a little bit of visible noise or splotchiness throughout. So just be aware of that with this method. It might be just a little bit of a limitation using this. I think that comes from just kind of pulling apart the RGB channels of that single layer and then reassembling them. And that just might be a side effect of that. You might also want to try denoising each of these or your complete final result in comp as well. That might help to minimize that. But as long as you don't push or pull things too much, you should still be in a pretty good place using this method nonetheless. So to sum things up, the straight up beauty method is the fastest approach in method 1, where I don't have that set up displayed here in Nuke. But again, it gives you no flexibility in comp, so it does have definitely a pretty big downside and limitation. The AOV shuffle trick here in method 2 does give you some control over the volumetrics as a whole, so it's a pretty good option there for you. And then the render layer techniques, whether they're per light EXRs or RGB packing, those kind of give you the most flexibility in comp with the trade-off of heavier file management, especially for this render layer setup here where we have render layers for each light source. Now, the thing that you have to watch out for more so with this one is that kind of quality degradation where you want to kind of keep an eye on that. Now, which one you choose really depends on your project needs and time constraints. Personally, I like having the render layer control whenever possible. But if speed and efficiency matter most, the AOV trick is usually good enough as well. And if you're in a bind, method 1 can also work if you have the time to kind of dial in those volumetrics as you might need to. That's it for this video though. I'm going to do a part 2 of this since there are a couple more techniques that I want to go over. But for now, hopefully this gives you a good sense of the options that you've got once you bring your volumetrics into comp.